Okay. I don't know if this needs to be explained. I think I talked a little bit last night. I don't remember. I started working on this project where I'm rebuilding a Brent Averill. Um, sorry about that. I'm rebuilding this power supply that was in here. It failed at the beginning of quarantine. I thought it was this part, which is the main switcher, switching power supply. I thought it had failed because when I opened it up to test it, I measured the two outputs of the supply, and they gave me 0 volts. And the supply does run fairly warm, so I just assumed that this transistor had cooked or whatever. The diodes looked okay, but you know. Anyway, I looked up this model number on it, which is IHB 28-1, and I ordered one on eBay. Yeah, that was like, I don't know, $50 or something. I probably could have. There were used ones that were cheaper, but I figured I already had a used one. It didn't work, so I ordered it and I replaced it in here, and the new power supply did not function either. It had the same 0 volt measurement, so I'm like, okay, something's up. And so I got into stuff, and there's this guy here, which I didn't know what it was. That is it's a voltage converter made by ERG Incorporated, and they've discontinued this item, and you can't get a replacement. But what it did is it took the 28 volts output from the switching power supply, and it stepped it up to 48 volt DC for the phantom power for condenser mics. Anyway, after doing some research on trying to get another one of these and finding out they were discontinued, I found a post on Gear Sluts where someone had successfully taken a power supply made by Meanwell, this little guy right here. It's a Meanwell. I'll never be able to read it. It's a Meanwell model RS2548. So I believe that means that it does like 25 watts and 48 volts. I can't remember what the specs were, but it was adequate. I'm going to get my reading glasses because I'm probably going to need it for some of this work. Excuse me. And I'm sorry for this kind of uncomfortable close-up, I feel like I should be giving a confession. The background behind me is actually adequately lit, but because of the amount of light that I've got on this workbench to film, and I only have one camera, and I'm using my gimbal to point at my workspace, so I got that tabletop there, and if I have to, I'll just reach up and move it around. But this is what I've got. So what I'm going to do, or where I left off, was that I had gotten this external power supply. The problem, it worked. I did mock it up and hooked it up, and it worked, and there's no weird funky noise or anything. There's no humming, no high frequency stuff. I think this is switching at like 125K. So well out of the audible range if it was getting in there somehow. The problem is that it would not fit, all of it wouldn't fit inside this box. It was just probably, 1/8 of the volume. It probably needs 1/8 more volume than this has. Either a little bit more, this way, or a little bit more this way, and I think it would have all fit just fine, but it doesn't. So I went out and I bought. It's not really my favorite option here, but I bought this. I bought one of these metal enclosures like this. It's aluminum. It's fairly lightweight, fairly flimsy, not great, but this thing just goes in the bottom of a rack, and and it lives there. It doesn't need to be, it doesn't move around. I'll get some rubber feet and put it on the bottom, and that'll be that. Oh, the one thing I don't like is the way that this is designed is I have to build, the power supply is actually going to be in here upside down, so that when I open it up, I can set it on a bench and be able to see it all. It's just a minor thing, but it means I'm going to have some screws and stuff on the top, which I'm not a fan of, but hey, it needs to work more than it needs to be spectacular in form. So what I've been doing, and why I decided to start filming, I did think I would live stream this whole thing, is I'm marking up the control panel. You can see I've marked a horizontal line there, and that's the center point of this panel, and that's going to be where I base the holes I'm going to cut in this. So I need to put an IEC connector, two 5-pin XLRs, a little hole for an LED, and I'm also replacing this wonky, can you see that? That little bit here, this is the way Brent Averill managed their fusing, and I'm going to move the fuse to a panel mount replaceable thing like that, so that, it doesn't have to be as stupid as that little guy. And for some people, if you search around on the internet, these, from the heat, eventually crack and break. Mine's never given me a problem, but, might as well make an improvement while I'm in there. Initially, I traced the these holes onto this panel, and since the unit is going to go from living in this orientation to that orientation, I basically what did I do? I'm gonna reverse what I drew on there, somehow or another. Did I do that wrong? I probably did. I don't really care. It's not that critical. I just want to make sure they're on the same horizontal plane and they don't, don't look like crooked teeth. And I'm doing all this as a tribute to my dad, who's probably in the last phases of his life, but he is the person who made me fearless about opening things up and fixing them. He was a body man in his whole career. He worked on auto bodies and took cars before, like, they used to really fix cars, like you would straighten out a car that was involved in some accident. And, my dad did that. He could take a tin can that had been wadded up and make it look like new again. And I watched him fix all kinds of crazy stuff when I was young. He was definitely like, while I wouldn't say he was an environmentalist, he was definitely a recycler. So if he found a battery charger or some, tool that had been abandoned because it had a problem, he would open it up and figure out what the problem was and fix it. And, I remember having this battery charger on our carport that looked like it belonged in a locomotive. He also had this drill, this huge power drill, and he used it to start our lawnmower. And the reason he had been given this drill is because I can't remember if it was like my mom's dad that had given it to him or if it came through work, but it had broken several people's arms. And what it was a big heavy-duty drill, not like something like this, but it had sort of a whole hand grip back here, and then this huge motor, and then the chuck, which was, it might have been a 1/2-inch drill. It was a real big drill. And it was all metal, sort of thing that you'd like to use in the rain. And it had this really mechanical, like all go trigger on it. And I mean, when you pulled that trigger, it would you pull back, and then it would click and maximum torque. And it had no like side handle where you could take it with two hands and be able to, have some control over all that torque. So guys would get into something with their arm straight on this thing and turn it, and it would kick, and of course your hand's inside like this D-shaped handle, and it would twist their arm and break it. So my dad got it, and he welded a bolt onto the side of this metal case, and then just got like a handle, like a bicycle handlebar grip, you know. And I can't remember how much of that he made or not, but screwed it in there, and so you could hold it with two hands. Became totally useful, and it was around long enough that like the electrical cord on it, you know, looked like something you'd see if like being a fireman has movies that are equivalent to those movies you watch in Driver's Ed where the ball rolls out and the kid's chasing it and you're supposed to step on the brake. This was the sort of thing that you'd be like, that needs to go. And it's probably still that way, and it probably still works and would break your arm if you were not using it correctly. So I believe I was talking about, you know, how this has to mechanically lay out, and I've scored a horizontal line here so I can make my tick marks for where the where each of these holes is going to be, and then I'm going to take my center punch and I'm going to punch in that horizontal line, and then start drilling these holes out so I can get that stuff in there. That might have been where I was. I know I explained the thing about using an external 48 volt power supply, and that's all going to work out just fine. I didn't like the mechanical layout that I was going to have to use. I believe that's where we were. Okay. How tall is this thing? No. Okay. So yeah, I'm just going to start trying to do this in some kind of logical way. So what I'm going to do is I'm going to put the first hole at 1 inch. I'm going to put the next hole at 2 inches, and the third hole at 3 inches, and then that'll leave half the space for the IEC connector. So I'm going to, like, I'll have a one of the 5-pin XLRs there, a 5-pin XLR there, the fuse holder right there, and then in the remaining gap I'll have the rectangular IEC connector. That's going to be my plan. I hope it isn't a disappointment. Where'd my little scribe go? I don't know if this is going to be a video. It's kind of sad, right? To talk about this kind of stuff. I care about my dad. I got where I am because of him. So, we are the sum of our experiences, and I watch a lot of. Well, I guess I watch a lot, but you know, like there's a lot of people on the internet who want to know how to be good guitar players or good recording engineers or whatever, and they really focus in on, you know, the specific act, and there's a lot more to my recording engineer skill set than the fact that I know where to put a microphone, or how to set a level, or understand gain staging, or, you know, that I hear sound and know what frequency range I want to be in control of with regard to that sound. And but one of the most overlooked things in all that I see on the internet is like the basic electromechanical element that can't be ignored in audio engineering. I mean, it's just astounding to me, the number of people that just kind of fudge past that. All right, I'm going to punch these and probably start drilling them and then figure out how the hell I'm going to do this IEC connector. I think it's going to involve a Dremel tool. So I put a horizontal line here, and then I marked 1, 2, 3, all an inch apart. Those are going to be the two 5-pin XLRs, and this is going to be the fuse. And then I took this distance, which is basically half the width of the panel, and I put a dot right in the middle there, and that's going to be the middle point of what will be the hole, the rectangular hole for the IEC connector. And then I used my my little center punch wherever I set it down, but I use these to make these marks, and now I've got my drill here with a teeny tiny bit. Maybe you can see it against my hand, I'm not sure. And so I'm gonna drill these holes. Probably gonna clear off a little space here to work. Okay. That'll be for the fuse holder. Okay, that looks pretty good. That'll be for the IEC connector. Normally I am a very meticulous mechanical engineer. I don't like this box. It's too flimsy, and I kind of overpaid for it, but my problem is that there's a certain amount of my there's a certain part of me that, like, I have to see things. Just looking at a spec sheet and taking measurements and all that, the way this thing is going to lay out on the inside is I'm going to have to decide on the fly, and this was the box that most closely fit what it was I was trying to do. So I bought it, and I'm going to use this stepped drill bit to open up those holes to be the appropriate size. It'll probably make a bit of a mess. I'll have to vacuum the floor. Oh, pardon me. Okay, so I actually need to expand that pilot hole just a bit in order to get that thing in there. Now I'm going to use that step bit to cut a hole that that this will drop into here and fit flushly on the top there. So. Almost. Woo! That looks pretty good. Oh yeah. Okay. So I got those two. That was my dog, Derby. Cool. Hey. All right. Cool, cool, cool. Okay, that's the whole show. I guess you could say that one of these things is kind of like an automated drill index, right? Just sort of steps up as you go. Very cool tool. I should have cut this hole so that this edge here, that's closest to the camera, was the edge, that, and then I could elongate it that way. Instead, I went for the center because I wanted to be in control of where the center was, but I realize now that that is a fool's errand. Okay. That's kind of a rack of the eye, best approximation measurement there. Definitely not exact science, but probably close enough. Okay, so I don't know if you can see that square there that I made, that rectangle that I made, but I'm gonna go take my Dremel tool and get to work on that. I went outside when I shut the camera off and to cut what would be the replacement for the square opening that is the IEC connector. So I've got my IEC, it fits in there. I've decided I'm going to front load it to kind of cover up my rough edge, and then this will be front loaded. This is a receiver that's front loaded, so everything's going to end up being front loaded, and I think it's going to be okay. I did kind of continue when I came inside and didn't restart the camera because I thought, oh, I'll just do this a little bit. Oh, and I'll do this a little bit, and suddenly I mounted this thing. I'm like, I need to get back to documenting. So I did leave my coffee, and I'll have to make a cut. All right, I got my coffee. This is the IEC connector. In order to front load it, I'm going to have to disconnect it from where it's soldered onto the power supply. And since I'm gonna change this fuse out, I'm just gonna cut this wire, and that'll allow me to insert my fuse receiver in there. I think it's all gonna be good. So yeah, so far pretty happy with the direction of this thing. So let's go ahead and. So do I cut the red wire or the green wire? I don't know. I think it's gonna be fine. I should turn on my soldering iron. It would be nice to have, a proper, well zoomed in top down, but this will do. All right. Boom. This should be free and clear. Yay! Shot 2, since I'm kind of down in my lap. Cool. Oh, that looks great. So my dad probably would have just repurposed something else. Or he would have cut a hole in the old box, or just some kind of crazy thing that would sort of look like hell. But, different strokes. Oh yeah, I like it. I like it a lot. Then we got to do one more of these. So in the original box, which is a heavier material, they tapped it. There we go. So I'm just cutting some threads with the screw itself. Little self-tapping action. And hole number 2. Oh, there we go. Looks like it tapped. So in a perfect world, the hole for the fuse holder would be keyed with 2 flat sides, but I don't have the tooling to do that, so we're just going to have a okay. This panel is almost there. Oh yeah. All right. So all of these things are officially mounted with a sufficient amount of torque to keep them in place. And I ain't no Bill Putnam, but this is how you keep the show going. The next part is going to be about getting this business mounted in here, which I'm probably going to do something like this. Now maybe We'll go with that. And I'm gonna clean this up, you know, make sure this stuff is gonna still work. So that this will be kind of in the center of the whole thing, and should make it feel somewhat more likely to be balanced. Boom. All right, there's number one. That probably clips the mic. Okay. There's two. Where is it? There we go. Boom. Okay. I started this project and coffee was an appropriate drink. When I finish this project, I think it's going to be a beer. I guess. Either way, I got to figure out how to get these holes in the right spot. Yeah, there was no paper in the box that would have given me like a template sheet. I'll figure it out. I could use my calipers and just come up with what the distance is and then mark it out. It looks like if I go with a 66 millimeter spacing, I'll be all right. So I'm gonna just basically match this spacing here, and I'm gonna take this, kind of eyeball it a little bit. Ping. We'll see how that works out. That doesn't even look like it's close. What in the world? Oh, I must have really tweaked my calipers. So I'm going to have one wrong hole. Oh, infuriating. I operate a lot of tools with my right hand, though. Can I use that as an excuse for drilling my hole wrong? I hate that. It looks like I just need to slightly... Oh no, it's right on the freaking money. I don't know what the pitch of this screw is, but it is a super fine thread. Just because I really like gratification. Here. These two things are a tad close together, but not really. I don't think I can slide off this. Oh, it just pops on. All right. I think that works. All right, the next thing I got to do is put this handle on there. But in order to do that, I may have to cut down the length of my screws because they are made to go through a cabinet door. This is just a regular drawer pull. Okay, so I did successfully cut the screws for the pull for the handle. I don't know if you can see those in there, but they're cut, and this gap from here to here is almost the same as the holes for the switching power, the 28 volt switching power supply. So I'm just going to drill a hole in here in line with these guys. Where's my scribe? I just saw it. There it is. Just make a little reference line around the center. Take this guy, Ow. So yeah, this is cool. I'm digging it. I'm digging it. Let me clean up these metal shavings. Did I mention that a replacement is $250? Hey, a quick editor's note. You're about to see a tiny moment in which just a flash of carelessness resulted in me losing a very important item that would frustrate me later. Okay, back to the video. And I am so far on the hours of this thing. I'm back at it. I took a little break. I had something to eat. I kind of noticed after I drank just a couple sips of coffee that it felt like my brain was going. So I think I was low on fuel. I made a few decisions. I mounted this with this part in here already. It's the 48 volt power supply. I also got this on. I can't remember if I did that on camera or not. I think I did. And I got to make some wiring decisions. You know, the one thing about doing a YouTube video about building something is you can't listen to any music because YouTube will, you know, tell you how lame you are for doing that. Wow. Gnarly. Somehow or another, I'm eventually going to make the LED assembly go in there. I'm sure it'll be fine. We got 1, 2, 3, 4. Yeah, I have a feeling this is definitely not designed for assembly. Oh, where did it go? That is almost a deal breaker. Sorry, you don't have a very good view. This under here. That. What did I do with that other spacer? Where did it go? It must have fallen, and it's a smooth round spacer. It's just a cylinder. It could have rolled a quarter mile. I'm infuriated by my missing spacer. I mean, just there are no words. None. And just so I don't lose this, I'm going to go ahead and put that in. This is the fuse. All right. I got to find that other spacer. I have a feeling it's rolled under the B3, which is behind the camera. I'm going to take a screw and 2 nuts and create a spacer of sorts. So what I'm doing here, you know, I kind of have talked a little bit about my dad and his means of problem solving, etc. Not perfect, not a complete failure either. Okay, so it's slightly heavy to the back, just slightly. All right, so now we have our unit here, and I just need to close a few gaps. I need to take a red wire and go from here up to there. I need to get this secured somewhere. Gray, white, black. White, black. Okay, so those are in place. Red one. Hot diggity. And then black one on that. Let's get all these together. See if we can get this all playing nicely. Okay. And then those two come together like that. Okay. And those look connected. Okay, now we gotta take our white wire. Okay. All right, and then okay. Okay, I could probably narrate a little better here, but I'm getting kind of excited and be able to smoke test this thing. Okay. All right. In theory, this stupid thing is operational. The only thing I have to resolve is getting this in here, which probably will take some glue. I might have some super glue I could use. Where do those little pieces go? Alright, here they are. So I believe it's something like this. This goes through here. This gets pushed through there. Oh. Ah, shoot. Okay, holy smokes. So really, the only thing that I got to do is hook up a power cable and see what happens. Okay, well, we got a real good sign there. I don't know if you can see it on the... I got an illuminated LED, which when this thing doesn't work, that doesn't light up. And if I unplug it, it goes out. All right, so there's my repaired Brent Averill. I gotta test it, but I feel pretty likely that the operation was a success, because before I put this in a box, I did set it all up and connect it to the preamp and tested it with a microphone and stuff. And all right, so I'm going to go ahead and assemble the rest of this. Okay. But I am very happy. I do believe that I have flathead screws. Oh, I know what I was going to say. So, in all my engineering on this thing, on my fabrication, I drilled one hole in the wrong spot, and that sucks. And somewhere I lost a spacer, but I used a couple of extra nuts to act as a placeholder. At some point, I don't know if I'll paint this. There it is. That is my rebuilt Brent Averill power supply with a functioning phantom power. I am going to go test it out. And if there is no add-on to this video of me troubleshooting why it doesn't work, then you know it does. Okay. My dad was a wonderful man, and there's no way I would be able to do any of this without what I learned from him.